Welcome to Martin's Institute of Teaching. In this video, we're going to be working on binary numbers, converting from hexadecimal to decimal, or from binary numbers into hex. So this is part 6. In the previous video, we worked with converting binary into octal and octal into binary. So this video is basically going to be the same as the previous video. We're just going to work with hexadecimal instead of octal. And you'll notice, if you watch the previous video, you'll know that, you'll see very quickly that hexadecimal is very similar to octal. It's basically the same, it's just a couple more numbers. So, hexadecimal, what is it? Well, what they came up with is a new number system. So, in binary, it's just zeros and ones. In base 10, well, it goes from 0 all the way through 9. So, in octal, it goes from 0 through 7 for a total of 8 numbers. Here we have a total of 10, and here we have a total of 2. So when we deal with hexadecimal, what we're dealing is from 0 to 15, or a total of 16 numbers. And here you'll see how they're represented. So in base 10, you go from 0 all the way through 9, and here is where in decimal, in base 10 is where we start to recycle the numbers. So we reuse every number, so 1 and 0, 1 and 1, 1, 2, in order to increase the numbers. But what they wanted for hexadecimal is just to increase it, to have a single digit still. So here, instead of creating some other number, they just borrowed A from the alphabet, and it's considered the same thing as a 10. B is considered as an 11, except A, B, and C, they're all single. Well, now they're single digits. So when you are counting through here, instead of restarting at 10, we're going to restart at F. So if we were to count using this, we'd go from 0 through F, and then as soon as you get to F, it's going to start recycling the numbers. So you would get a 1 here and a 0 here, and this would it would continue all the way down to F. So you'd get 1, 1, all the way to, then you get into 1A, and then from 1A it's going to continue into 1F, and then as soon as you get to 1F, it's going to go to 2, 0, and it's going to continue on just as if you normally would. It's just as soon as you get to F, it's when it's going to start over. You're going to go with a 0 and a 1, and it just continues on like normal counting. So enough talking, let's go ahead and start working on some of these problems. So let's see, scroll down a bit. So now let's say we have in octal, let's say we have this number F, F, F. So if we have 3 F's in hexadecimal, what you're going to do is let's focus first on this first F. Now this first F is in hexadecimal, it represents 15. So in order for us to represent 15, we're going to use 4 bits in binary. So so if we wanted to make 15 in binary, we'd say 1, which is a value of 1. You'd put another 1, which is plus 2, 1 more, which gives you plus 4, and 1 more, which gives you plus 8. And 8 plus 4 plus 2 plus 1 is equal to 15. So 1, 1, 1, 1 represents 15. So for the first value, we'd get 4 ones. For the second one, it's exactly the same thing, so you'd write 4 more ones. And for the last F, it'd be another 4. So if we were to convert F, F, F into binary, we'd get 12 ones, just like this. So let's go ahead, now let's convert another number. Let's say we have a smaller number. Let's say we have 7, 7A, and let's go with 4. So we do the same thing again. So for the 7, we would have 4 bits, and to make a 7, it's 0 and 3 ones. A is represented by, I think A is 10. Yeah, A is 10. So we'd have to make a 10. So in order to make a 10, we would want a 2 and an 8. So we would get 1, 0, 1, 0. That represents 10 in binary. And 4, if we come over here to 4, it's just this one right here. So it would just be 0, 1, 0, 0. So 7A4 is the same thing as this binary representation down here. Okay, so now let's go ahead and take a binary number and convert it into hex. So if we have, let's say 1101 1001 0001, then let's see, anything else? 0011, just for fun. So normally you won't see them grouped like this. You'll see them all together. So if we were to just to put this all together, it would just be 1101 1001 0001 0011. But when you see it like this, in order to convert it to hex, it's much simpler just to put them into groups of 4, just so you could see them, just so it stands out a little bit better. So let's go ahead and do that. I'm just going to erase this. So if we were to do this, the first number here, 1101, this is a 1 plus a 4, so that's 5. 5 plus 8, that is 13, so this would be a 13. Of course, 13, we have to convert it. I have to see what it is. I forget what it is. 13, that is a D. So 13 is D in hex, and this is 1 plus 8, so this would be a 9. And 9, well, that's just the same thing as a 9. And this is a 1, so it's the same thing. And this is 1, 2, 3, so it's just 3. And this binary number is the same thing as saying D913 in base 16 or in hex. So here we've converted this binary number into a hex representation. So let's go ahead and so if we have 0001, this is the same thing as just 1 in hex. If we have 0010, that's the same thing as 2 in hex. And if we do, let's see, 0011, that's the same thing as 3 in hex. 0100, that's equal to 4. 0101 is equal to 5 in hex. Let's see, 0110, that's equal to 6. 0111 is equal to 7. 1000 is equal to 8. 1001 is equal to 9. Let's see, then 1010, that's equal to 10, which is equal to A. And then if we go with 1011, that's equal to B. And if we do, let's see, this is 8, 10, 11, so now we want 12, so 1100, this is going to be equal to C. 1101, that's equal to D. Oh wait, I think there's something wrong here. Did I forget something? It's the A, B, C, D. This is 10, 11, 12, 13. Then if I want to do 14, it's 1110, because it's 8 plus 4 is 12, plus 2 is 14, C, D, that's E, and then 1111, that's equal to F, which is 15. So that's all of them written out, maybe not the neatest. Maybe I could rewrite this bottom to make it a little bit neater. So this is 1110. Yep, so that is all 16 of the bits before they start to recycle again. So this is the largest number you can make with 4 bits, and this would be hex. And so when you start over with the next value, you start over with another 4 here, whatever they'll be. So let's see, let's do another example of that. Let's go ahead and scroll down a bit. So let's say, let's see. Okay, how about 7, 8, 9? So if we're going to convert this into, this is base 16, if we're going to convert this into decimal, well, 7 is just 0, 1, 1, 1. 8 is just 1, 0, 0, 0. And 9 is represented by 1, 0, 0, 1. And that's in base 16. Well, this is kind of big to be a subscript. Yep, so this is how you would represent 789 in hex. Well, this right here is a representation in binary of 789 in hex. I think that's basically it. Alright, so in the next video we're going to start actually playing with adding these two values together. How to add between hex and octal and binary. So, alright, I hope you enjoyed the video. If it helped you out, great. If any of this seemed a bit confusing, like converting over, I would recommend you watch the previous videos. In the previous videos, I'll go into more detail about how to add this stuff. So, alright, I hope you enjoyed the video, and good luck in your classes.